Hi students, welcome to my channel Excellent Ideas in Education. Today we are going to solve this problem. A sphere of weight 100 Newton is tied to a smooth wall by a string as shown in figure. Find the tension T in the string and reaction R of the wall. In this question we need to find tension T in the string and the reaction R of the wall. First we will draw the free body diagram of sphere. What is given in this question? A sphere of weight 100 Newton is tied to a smooth wall by a string as shown in figure. This is the string. The weight acts always vertically downwards passing to the center. The center of the sphere is this one. So weight acts always downwards. W is equal to 100 Newton. Next, you see here this sphere is connected to the string and the angle is given as 15 degree. This angle is given as 15 degree. This is the parallel line. So I will draw the parallel line to the center of the sphere. So we will draw the parallel line center of the sphere. You see here, this is the wall. This angle is given as 15 degree. Now we will draw the parallel line here. So this is 15 means this is also 15 degree. This is alternate interior angle. So this angle is 15 degree. Next, you see here, this is the wall. The string is connected here. So here one force acts. After that, you see the sphere is here. The wall is here. So here one force acts. So this force is tension. So tension is created in the upward direction along the inclined line. You see here, this is the inclined line. The tension is always in the upward direction. So we will write it as T. Now we will draw the vertical line. So this is 15 degree. Now we will draw the center line. Next, you see here this wall and sphere is touching. So here one force acts. This force is reaction force. You see here reaction R of the wall. This reaction force acts perpendicular to the wall towards the body. So we will draw here. This is the reaction force. This is the perpendicular to the wall towards the body. This is R. Now we will solve the problem in two ways. First, we will use equilibrium condition to solve this reaction. Second, we will use Lami's theorem, but only one condition is there. Three concurrent forces required to use Lami's theorem. You see here, this is one concurrent forces. This is another concurrent forces. Or is third concurrent forces. So we will use Lami's theorem to solve this problem. Next method we will use equilibrium condition to solve this problem. First we will use equilibrium condition to solve this problem. First method, equilibrium condition to solve this reaction. Summation of f of x is equal to 0. You see this graph, x is this direction, y is upward direction. Upward means vertical. X is in horizontal direction. Horizontal direction, this side is positive. So we will take summation of h is equal to 0. You see this inclined force. First we will resolve this force vertical and horizontal direction. Now we will resolve the inclined force. So inclined force only T. So we will draw the inclined force. So here is vertical, here is horizontal. You see the arrow is this direction, so we will draw this direction. You see here the angle is this side, so we will draw the angle here. So the angle side is cos. So cos 15 degree. So T is there, we will write T. Another side is sine. So T sine 15 degree. We will resolve the forces in horizontal direction. You see here this R, we will draw it this side. So I will draw this R is this side. R. Now You see the horizontal direction. So the R is in the horizontal direction, is in positive. You see, arrow goes this way is positive. So plus R. Next, you see the arrow. The arrow goes this side, opposite side. So opposite side is negative. So minus T sine 15 degree. So any horizontal direction is there? No, right? So equal to 0. R is equal to T sine 15 degree. Next we will take vertical. Summation of f of y is equal to 0. Vertical direction, this side is positive. Summation of v is equal to 0. Now we will see only vertical forces. So vertical forces, you see, arrow goes up, right? Up is positive. So T cos 15 degree. After that, you see the arrow comes down. Up only positive, down means negative, minus 100 equal to 0. T cos 15 degrees equal to 100. T is equal to 100 divided by cos 15 degree. T is equal to 103.53 Newton. This is, we will take it as first equation. Now substitute T is equal to 103.53 in equation 1. So the equation 1 is R is equal to T sine 15 degree. R is equal to T is 103.53 into sine 15 degree. R is equal to 26.59 Newton. Sine 15 degree is 0.2588. Cos 15 degrees 0.9659. You see, in this question we need to find tension and reaction R. This is the answer for this question. This is the first method. Now we will see second method. Second method is Lami's theorem method. Why we are using Lami's theorem method? You see the condition, three forces is there, three concurrent forces is there. So we will use Lami's theorem also in this case. Now we will draw the concurrent forces. T is here, this is 15 degree. So R is here, W is here. So this whole angle is 105 degree. This is 90 degree. This whole angle is 180. Whole is 180. But we need only this. So 180 minus 15 is 165 degree. I will draw the drawing again here. This is R. This is T. This is W. So this angle is 105 degree. This angle is 165 degree. This is 90 degree. T by opposite only we will take. Sine 90 equal to R opposite is 165. So R divided by sine 165 degree equal to, next is W. W opposite is 105 degree. W divided by sine 105 degree. So W is, we know, 100. So we will take this is as a 100. Next, you see here, this is 100 by sine 105. This T value, this R value we don't know. So first we will take this 2. R by sine 165 degrees equal to 100 by sine 105 degree. So this one goes. So R is equal to 100 into sine 165 degree divided by sine 105 degree equal to 26.79 Newton R value. So sine 165 is 0.2588. Sine 105 is 0.9659. Next, we will take this and this. So t by sine 90 degree equal to 100 by sine 105 degree. So t is equal to 100 into sine 90 degree divided by sine 105 degree. So t is equal to 103.53 Newton. So sine 90 is 1. Sine 105 value is 0.9659. You see the first method answer and second method answer is same but concept is different. Which method is easiest for you, you can follow. Thanks for watching this video.